Chapter 5, Section 2, Part 2. Just picking up with these radical properties that we're extending into rational exponents and into radicals of bigger indexes than square roots. So, the properties of rational exponents and radicals can also be applied to expressions involving variables. Because a variable can be positive, negative, or zero, sometimes absolute value is needed when simplifying. So there's a rule where, because we don't know what it is, we want to make sure that we get the right kind of number in there. And so when we are doing the nth root of a variable to some exponent, they've got n on both in this instance, but to some m exponent. If you're taking the even root of an even exponent and get an odd exponent answer, you have to put the variable that does that in absolute value. The reason is we want to make sure we get the positive answer. Because odds will be either negative, 0, or positive, we don't know that we're going to get the right one. So we want to make sure that we do. So when an even root of an even power gives you an odd power, use absolute value bars. So I've got an example. The fourth root of x to the 8th, y to the 12th, z to the 16th. Even root of an even power, and then we get an even, right? X squared doesn't need the bars. But an even root of an even power, and we get an odd, the y does need it, but then the z doesn't. So only the y gets it. You don't have to do it to the whole thing. So just keep that in mind as you're making your answers, because that will make the difference between a right or wrong on a quiz or a test. So simplify. Third root. This is an odd, so we don't have to worry about the bars. All we have to do is third root it. So 64 is 8 times 8. 8 is 2 times 4. 4 is 2 times 2. I got 3 2s. I got 3 2s. 2 2s come out, so 4 comes out of there. And divide on the variables. If you remember, we're going to just divide the exponent. However many times it goes into it evenly, that's how many exponent numbers you put on the outside. So 3 does go into 6. It goes into 6 twice. And that eliminates all of those. And so we get that one. Now, when we do the fourth root, we have to watch out for that even, odd situation. We kind of have it here. We're going to divide that one by 4. We're going to divide that one by 4. We get x to the first, even, odd, absolute value. And y squared, even, doesn't need it. Looks just like that. So write each expression in the simplest form. Assume all variables are positive at the moment, so we got to bring in those bars as we need to. There isn't a fifth root of 4, so that's going to stay in. 8 divided by 5, it'll go once with 3 left over. 14 divided by 5, it'll go twice with 4 left over. And 5 divided by 5 goes once. So we got, to write it clearer, a, b squared, c, fifth root of 4, a to the third, b to the fourth. Stays inside. X divided by y, so we're going to divide by 3. It's an odd root, so we don't have to worry about the bars. The x stays on top. Some y gets to come out. 3 goes into 8 twice. Third root of with 2 left over. And then c, 2 goes into 14 7 times, so that's done. X and 3/4 x, that's going to be x to the 1/4. And y to the 1/3 doesn't change because there's no y on the bottom. And z gets to move from bottom to top. And that's as simple as it gets. You could put them into radicals, but none of the radicals are the same, so that's all we need to do there. Perform each indicated operation, assume all variables are positive. So we may have to move these things around a little bit to get them to look the same. So we can do it, but when you're adding and subtracting, it's just that coefficient number, and you need to have like things. So here we have square root of y and square root of y. So I literally have 5 of them plus 6 of them is 11 of them. Over here, I've got cube roots of 2z to the 5th, and I got cube roots of 54z squared. Well, those are not like each other, so I got to like them up first. So there isn't a cube root of 2, but I can divide the 5 by 3. So I get 12z, 3 goes into 5 once, with 2z squared left over. Ah, I see. And then the 54, we need cube roots. That's the wrong line. There we go. Break that apart. 2 and 27, 3 and 9. 3 and 3, there's 3 3s, the 2 stays in, so minus 3z cube roots of 2z squared. Now, z cube roots of 2z squared and z cube roots of 2z squared are like things, so 12 of them minus 3 of them is 9 of them. They've got to be completely like things. Okay, 4 to simplify. Be careful with, double check the ones we did back here. Nope, no even roots, so we're good. Be careful of even rooting something and having to get an odd, even odding. Be careful of that. So try 13, 14, 15, 16. Pause, come back, see what the answer is. All right, let's do this. 27 cube root, 3 times 9, 3 times 3, 3 3s, so 3 comes out. Q to the 9th, 3 goes into 9 3 times. 5, so that's x squared over y. Odds, so we don't have to worry about that one. 3 divided by 6 is 2. X to the first, 1 minus 1/2 is x to the 1/2. Y to the 3/4 minus 1/2. 1/2 would be 2 times 2, which is 2/4. 3/4 minus 2/4. 3 minus 2 is 1. So we got y to the 1/4 there. Nothing on the bottom after that. And let's see. Well, 9 square roots to 3 times 3. So we got 3. And 2 goes into that w, square roots of w to the 3rd minus w square roots of w to the 3rd. This is all the same as this. Don't forget we have one of those, so 3 minus 1 is 2 w square roots of w to the 3rd. Just like that.